Let's do this problem from section 7.2, problem number 2. They want us to find the integral of dx divided by cosine x minus 1. And so what I want to try to do is try to include the sine squared plus cosine squared is equal to 1 formula. And I'm noticing that this is almost a difference of 2 squares. Well, this is one factor of a difference of 2 squares. So the other factor, if I were to multiply the bottom by cosine squared or cosine x plus 1, I would get cosine squared x minus 1 in the denominator. But that means I have to multiply top and bottom by cosine squared minus or cosine squared plus 1. So then our integral should be the numerator is just going to be this cosine in the numerator, and then our denominator would be this, except it'll be squared. Cosine squared, it'll be the difference of 2 squares. So let me put that there, put the square on. And then that's it. So the denominator will essentially become sine squared. Actually, cosine squared plus sine squared is equal to 1. So if we do some fiddling around, this is going to be a negative sine squared x. And then now we can deal with the numerator in a sense that it's a couple of terms that we're adding, so we can just split this up to 2 different integrals. So let's split this up into 2 different integrals. First integral with a cosine, and then an integral with a 1. All right. We can also just take this negative sign out in front of each of these things. Oops, I have too many symbols here. And so here's what we have so far. All right, now we want to find the expression for each of these things. Let's first start to figure out what this is going to be. I think a good way to approach this is if you let u equal to sine x, then the du is going to be cosine x dx. And so that's going to cover our bases here. If you let u equal to sine x, then du is going to equal to cosine x dx. And then this will become just our integral then will become a negative integral. Oops, my font got bigger. So the integral with a negative out in front, and then we have a 1 over u squared du. So u squared, the integral of that is 1. It'll be u to the negative 2, the integral of u to the negative 2. If you add 1 is u to the negative 1 divided by negative 1. And so that's just going to equal to 1 over u. And u was equal to sine, so this is 1 over sine x, which I think is cosecant of x. We'll put the plus c later, but so far we have cosecant x as a result. Now we still have one more expression here to deal with, so let's figure out what this is going to equal to. So we want the integral of this. This is just equal to the integral of cosecant squared of x. And I think we have a formula for that. The cosecant is the derivative of cotangent is cosecant squared negative, and so let's throw a negative. So we have a negative there, and then we have a negative cotangent. And so that would be positive cotangent. So we're going to end up here with a positive cotangent of x. And then we'll put the plus c. So it looks like this should be cosecant x plus cotangent x. Let's see if that's going to be good for us. And then don't forget the plus c that they asked for here. Alright, so this is a little bit tricky, and the trick is to try to get that sine squared plus cosine squared is equal to 1 formula, the basic identity, going for us. And then we can get that by multiplying the top and the bottom by cosine x plus 1. Alright, I hope that helps.